Greetings, everyone. This is Eric Amdolin, Senior Photogrammetry Workflow Specialist with SimActive, and you're joining us for the webinar, 4 Tips to Success When Mapping with Drones. And with me today, I have my guest, Gordon Morris, owner of GMAPSNZ. NZ stands for New Zealand. Gordon, say hi to everybody and give us a little information on your company and background.
Well, hello, everyone, and kia ora to those people in Aotearoa, New Zealand. I'm Gordon Morris, and I run GMAPSNZ, which is a small company, and I've been using the aerial systems for the last 10 years or so. My background's with the New Zealand Army, and since I left, I've been working with a number of really interesting companies and industries and people to really bring out the best on their geospatial and aerial mapping.
That's great. So I would say then you have a military background that you turned into a career just like myself.
Yeah, so I was geospatial intelligence. So that allowed, I raised, trained and sustained the geospatial side of the house, yeah.
Very cool. Okay, so in this webinar, we are going to talk about 4 tips to success when mapping with drones. And we all know that there are more tips than that, and that you and I will probably ramble around on that subject. But in general, we'll try to cover these 4 points. Planning for what you are mapping, choosing the right drone for the mission, developing processing workflows, and then finally, understanding options in correlated 3D. So with that said, let's start with the first topic, planning for what you are mapping. And again, it's a broader term. And I know you have a background in the military where you were working with drones and payloads and so forth. And I suspect that what's carried over is not only, the drones and the payloads, but again, looking specifically at what missions you may be acquiring data of, what sensors you might use, what are the pitfalls, what are the best practices when it comes to, setting up something like that. A lot of people just think, hey, I can go buy a drone. Either, it could be cheap, it could be expensive, but, I'm just going to go capture it, map it, great success, and life is wonderful. And, again, part of the reason I have you on here is you have, 10 plus years experience in doing this, and you probably have some tips to share with folks on, what they should be doing. So give us your thoughts on, again, choosing the right drone for the mission or preparing yourself for missions in what you're going to fly.
Yeah, well, thank you, Eric, because my background within a military perspective use these as a platform and as a sensor to undertake a particular task. But when you come into a civilian environment, you're owning the whole system and a platform and all the parts together. So trying to make it work for you, sometimes it's overwhelming. So having some discipline and some structure and some tools to enable that are really key to really making the effective use of your very expensive asset. So while it might be a whole lot of drones out there, you still want to be able to maintain even your drone. For example, you buy a drone and it's a nice kit, you take it out into the field, but you find you've only got 1 or 2 batteries. Well, your flight time then is very limited. So your day length, your ability to capture data is also limited. So when people come to me with data sets, sometimes they're flown over many, many days. And partly because they haven't had the resources to generate income to then get extra parts for their drone. So that's where someone like myself comes along, gives a bit more of a discounted offering for their processing so that they can then buy some extra equipment and then go out and fly more. So the discipline really is in looking at their entire system, not just I've got a drone and I can get data, or I've got this piece of kit and I can go get something. It's actually about, or I've got a problem that I need to solve. It's looking at that whole wide range. And so those sort of structures about maintaining the data isn't just about having data that I acquire and I throw to someone else. It's about taking my data and being very disciplined and careful about it through my steps of acquiring it. I look at it and I make sure that I'm actually in the right place, through to I'm confident that this information meets my end user's need, and being able to sign off on it with metadata, so that in a year's time, when someone comes back, they can look at that information and they can look at the data behind it and realize, yes, this is what I was trying to solve with this particular data set. So those are sort of the key parts of how a person might come into a mapping process. Yes, sure, they've got to solve a problem, but it's about being disciplined across that problem so they can actually solve the problems that they're trying to solve.
Yeah, and I would say that, adding to that, or maybe expanding on it, if you're flying an area that's flat,
Yeah.
then your mission planning is a lot easier. The amount of effort maybe to get out there is a lot easier, things like that. Whereas if you're mapping a remote location or something like that, I guess what I'm getting at is way before you actually get out there and map, you need to determine where the location's at, how long it's going to take to ferry there, how much time you're going to have to fly,
absolutely.
how many hours in the day will you have to fly, how many batteries are you going to need to do that project, complete the acquisition, field check it if you're going to field check it, all that. So it means you probably have to have some kind of reception, all those things, or not. And who knows? Maybe you're not running PPK and you're running traditional survey, and you also need to have a survey plan set up. A relationship with a surveyor that works for you guys, so you understand what each other wants, or what the deliverable might be. So those are also other things that certainly should be considered. In the beginning of this process.
Yeah, and you touch on a point there too about putting surveys. So if you want to have control over your data, or you feel like you need to exert control over your data, then working with a surveyor, a specialist surveyor, is key. But I think the real trick in there is being able to share with that person who's going to do that role what you expect from them, and likewise what you expect to see, what they might expect to see from your data as well. So that discipline says, I'm not just sending you something and telling you to do a task. It's about, this is what I expect. This is my intent. This is what a data format I require it to be in, and being really quite precise, not telling them exactly where to put the peg on the ground, but to be able to convey that information back to you so you can use it. I mean, if you're paying them for the data, you want to be able to use that data. So
very nice. So, I mean, you're getting to the point where you're really talking about the pre-planning, maybe even to the level of making sure that you have, back in the old days, log books, log sheets. I know, again, originally we started with paper ones that we created ourselves, and then some companies came along with flashy apps to do all that, and you can pull it from DJI. But the reality is, depending on whatever drone you're using, but the reality is you really need to track what you're doing, keep metrics on projects that you've done, what the outcomes were, what the deliverables were, who maybe your surveyor was you worked with, also your client, what your client wanted, the clarity of the deliverable, did you meet their needs and all of that, and that also needs to be documented and in an SOP or in workflows or something like that, correct?
Yeah, well, that's where likes of the background and structure that a military environment has kind of bled over into what I do. So that forms-based approach, having a form that says, what's the end user looking for, and understanding their intent. what are they going to use this for? Oh, okay. So they might want to have this particular data. They might really want to use the surface model that's created rather than just the aerial mosaic. Okay, they really want to see a true ortho, not just a straight cut line. Oh, I need to do some work on the seam lines with this. And so that's also understanding your intent, the intent of the end user. So that forms-based approach can sometimes work very well, especially if it then works through into the production line that you set up. And that's I think the beauty about Correlator 3D, that it does offer itself to a production line process, as you've had presentations on before about large scripting and the likes.
All right, so not that we're moving on, but we'll move on a little bit. I just wanted to talk a little bit about choosing the right drone. And we've all been through this before. You've got fixed wings and multi-rotors. What determines which you're going to use has a lot to do with the amount of area covered and the accuracy required. So maybe a small quadcopter is good for small projects. Maybe where it's extremely windy, it's going to help you out. Whereas a fixed wing is going to work better for you on larger projects where you need to capture a bigger area. And again, the accuracy can rival something from a quadcopter with lidar, but it's typically photogrammetry. We're starting to see some lidar on drones that are fixed wing, but those are the real things you've got to weigh. And then of course, weather, where you live, you've got, changing conditions all the time. You've also got changing terrain, and those things can affect how you might again set up a project. And as we talk about choosing drones, really we're talking about how to best run the project. So maybe continue on in that vein.
Absolutely. But as a production person, I will never tell a pilot how to fly, because there will be conditions on the site where unique to that site, and that's their craft, that's their skill to be able to fly on the day. But if we can make suggestions about whether to fly into the wind or against the wind, and then what time in the camera might have for that, because then you've got your leg coming back, which is with the wind, and so your interval might be the same timing, but you've got greater spacing, so less overlap. So that's one of the beauties about with Correlator 3D comes in, to be able to have a terrain model that you can drape those images on, which may have a not so great overlap for those particular areas, and account for that. And of course, the correlated to that is, do you fly a crosswind into these things? And the disturbance that especially smaller drones will have in higher wind speeds. So this is again being able to select those images that are the best, the most nadir, the ones that are actually going to produce the best quality product for the visual overlay. That's one of the beauties about Correlator 3D that certainly I've found.
So that leads us right into our next topic, which is developing workflows in Correlator 3D.
Yeah, so obviously the end user is key here. So it's really understanding that you need to do a certain amount of work in order to get this end product over the line. It's not about skipping corners. It's not about making a lesser quality product. Being efficient is really what this is about. So you could bring together a number of areas and process them all at the same time. And this is the beauty I like about Correlator 3D, so that I can bring in thousands of images into processing, not just do the one area after another area after another. No, bundle them all together. There's an economy of that SymActive Correlator 3D really brings together for a production line. And so that's the beauty, I think, where yes, you can go out and fly day on day, then bring it back, bring a week's data back out of the field and process it through with the tools here, instead of having to process overnight and then worry about the production line and getting it through. No, bundle those tasks up as one, and then run it through with SymActive. I mean, it's just this is the beauty, real key for Correlator 3D. I can't say it enough.
So along with that, another key feature of Correlator 3D is that it allows you options in what you're doing. So not only can you create a DSM, but you can create a TTM. You can create a true ortho or just a regular ortho. And you can also script all of these things. So we're not just talking about doing one thing within Correlator 3D. We're talking about getting you all the way through to almost a deliverable for your customer.
Yeah, people need to take advantage of that, and that's really what this law is really about. So that instead of kind of doing it day by day by day and worrying and fretting and trying to get things, no, bundle it all together, and then you can concentrate the production line and the quality assurance that goes with that. In one simple time, you've got your mind focused on that particular activity, and then you can really work on the results that they need to be as well. Another really good one too is that here in Aotearoa, New Zealand, we generally would like to tile our data sets into basically part of the map sheets. So cropping your data to a nice, neat area and making it presentable for a local authority to use in their mapping schema. Correlator 3D does that super well. I mean, far better than trying to go into another third-party product or muck around. No, it just happens inside the product. And that also is a lifesaver for someone like myself.
Yeah, so again, we've got options in your processing. We've got workflows that will allow you to
Definitely.
duplicate effort when it's kind of the same project. And then, of course, you've still got the scripting, which is beneficial because then you can run your projects all the way through,
Yes.
either without opening Correlator 3D or by running one of the automated workflows. So I think it's a real advantage.
Absolutely. So those are the things you do at the beginning of your task. And that's where the discipline of having quality assurance right at the beginning happens. So you've got that ready to go as soon as you are pushing the button.
Yes, absolutely. Build your plan, basically before you execute. Have that, as you call a law, um, you know, ingrained so that you're being consistent in what you're doing and how you're collecting. And then, maybe also you manage expectations of your users. Sometimes they're told, "Hey, I can get this great accuracy," when in reality, maybe they don't need that. Maybe to get faster data, they can work with data that is, I'm not saying less robust, less accurate. I'm just saying,
Correct. Yeah.
plan and collect and process to a
Yeah.
specific accuracy or accuracy standard, and that's pretty important too.
Yeah. But likewise, people should sometimes push back as well. So if your mission planner tool tells you that you've got a 1.7826 centimeter resolution availability, is that really going to work? How are you as the supplier of this data going to push it across? If it's just a flat map of pasture land, there's something kind of wrong. Maybe looking at what the end user is really looking for. Perhaps they're looking for that high resolution in a very specific area for drainage contouring or such like, but maybe not for the wider area. So your job is to think spatial and to be their trusted advisor with that, because you've got the subject matter expertise in this field. So sometimes you can push back and say, give a bit of advice as to how to make the product work better for the person who's actually going to receive it.
Yeah, well, there you're speaking the truth, because if your customer can't use the data you provided, whether that's because of a format issue or because they were looking for a DTM and not a DSM, you have to really be aware of what they need and how to provide that output to them.
Oh yeah. So Correlator 3D offers, to me at least, the flexibility to do a whole range of tasks. So not just necessarily a production of orthos to find a mosaic. No, it's about finding the ability to create 3D models, to make terrain models that are really unique and bespoke for a particular site, indeed even physical terrain models as well. But likewise, the ability to reach back into time and undertake historical mapping analysis. That's been one of the key feature of some of the work I've done, especially for Indigenous First Nation groups, Māori here in Aotearoa, New Zealand, to be able to take aerial photography that's available through a scanned process called RetroLens here in New Zealand, and offer that up for their particular reach back into time. And so SimActive Correlator 3D actually offers me the ability to do that, as opposed to trying to find and stitch together. I know that some regional councils use other web-based tools and graphic tools to stitch together aerial photography. For me, no, the best way is to use a tool like Correlator 3D. That gives me the flexibility to use other data sets as opposed to just a straight take a photo, put it in.
Well, you're right about that, because a lot of times existing data sets are out there, but they may not be of good enough quality for what you want. So that's pretty good to be able to just simply use it to stitch together what you captured with a drone or what someone's captured with a drone, and work with it from there.
Yeah.
Not to mention, there's other products that you can create from those, old imagery or things like that that you can bring into Correlator 3D.
Yeah, and it's not just the aerial imagery as well. It's also the terrain. I think people forget that. So the ability to recreate terrains from historical imagery, I haven't been able to do that with other tools. Correlator 3D is just magic.
Well, I think we've covered everything we need to cover. With that, we'll probably pop into a little bit of a demo. All right, so as Gordon drops out, we will pull up this example of his. So this is a project that Gordon was working on previously, and it was flown with drones. The purpose was to capture difficult and challenging terrain in an area with efficiency, practicality, and safety, plus being respectful to the landowners at the time. So we have roughly 228 images from a Sony camera, and you can see the flight lines here. You can also see the flight direction. And since we're talking specifically about managing projects and so forth, you'll notice that there is a gap here of imagery. That was on purpose. This area was not part of the contingent area that he was working with. So that's why those images are not there. And again, we talked about being efficient with your images. So that's an example. If you don't need it and you're short on time, go ahead and go on without it. So we have the imagery. Of course, you can look at any individual image. If you just click on it, it'll show you that image as it loads it in the area. And this is actually very hilly terrain. Let me turn off the images and maybe go to a 3D view. So we'll go to a 3D view and tilt this on its side, and you can see you've got quite a bit of relief in this area. So, a challenging area to capture for sure. You can see we've got some clouds in the area too. Possibly, it's New Zealand, so you're going to expect to see those. I just wanted to, show everybody that you can move between 3D view and top-down view using this button here. So that's one of the features we have, and you can use that for QC, anything else. Of course, we've got all of our layers. Again, the images were on here. We have our AT here, so we could take a look at that if we actually load the AT. It'll take just a second. And you can see because he was using, an RTK solution when they flew this, they've got pretty tight data, even where they have little tie points. And, that would kind of make sense when you're over dense vegetation, you're going to have challenges with tie points. What I would say there is that the higher you fly, the better. It gives the software more room to make those type of corrections. And see, we've actually got a little bit higher altitude flight over here, which again, Correlator 3D can handle no problem. So this is the final step of the AT, and we can actually look at the results here. And the results are shown here. Of course, we're in New Zealand, which is pretty cool. Everyday stuff for Gordon, but not for us. And as we go through, we can see what type of sensor was used. Again, right up here, we've got a Canon sensor, and we've got our AT results, and showing very little issue there, and accuracies less than a pixel. And you can see the shift, all of that. And again, it's our standard AT report. If we had control, if we had ground control here, it would also be listed in here as well. We could actually look at the display report for the second step as well. And you can see that, originally these all came in raw, and then the adjustment was made. So that's something that's understandable and you would expect. So again, that's where we can access our AT information, our quality reports. So if we had ground control points, we could see those in this AT report. The other place to find the AT report is in the IEO folder in the processing folder. So you could find it there. And we'll pop back out of AT, and we can look at some of the DEMs that were created, that Gordon created. And we can see that he's done a little bit of additional work here. We've got the original DSM, which is right here. And we can go ahead and turn off the images real quick. And we can take a look at those. Images and mosaic are off. So here is the original DSM. I will go ahead and turn off the imagery and flip to 3D. And again, we get a nice view of what that DSM looks like. And you can see the vegetation up here in the trees and so forth. But the river, the valley itself looks great as we see meandering through there. And this project again was for landowners in the area. So there are multiple landowners in this area. They wanted to see what was going on with their property. Maybe they're either not on site or they don't have access to what's around. So Gordon and his team processed this data set to help show that information. And it was processed rather quickly. So then, being the scientist nerd that Gordon would be, just like me, he did some other refinements to the data set. Of course, we have our DSM. So now we can go to our DTM, and you can see we've got that there. Looks pretty good. And I'll zoom out again. And he had a couple of other variations of surfaces that he took out of Correlator 3D, modified and brought back in. So this one's a DSM with the optimal highest values. So he's kind of created a DTM based on high values. So you've got that. Something similar here. That's the DTM based on those high values. So, you can look at that as well. And again, the nice thing about again, Correlated 3D is you can edit surfaces outside of Correlated 3D, bring them back in and work with them from there. You could go ahead and recreate the orthos that way. You could recreate the mosaic that way. You have actually quite a few options there. We also have the point cloud, which I think is just fantastic. If you take a look at this, and I'll zoom in and out here and manipulate it a bit. So as we zoom in to the nadir image, we get to see more points. In other words, correlated 3D brings in more points. So as I zoom in here and zoom out here, we're going to see more points, and that's almost a photograph there. And in fact, the point densities rival or even do better than LiDAR point clouds. Now, of course, there are differences, like vegetation and so forth. But if you want the raw point cloud colorized and ready to go, man, this is a way to do it. You could see the roads, you could see the structures. Again, and this is from a fairly high altitude flight. So with drones in New Zealand, something they can do, probably something that, we wouldn't do here in the States, but just fantastic detail. If you want to provide something similar to a model to your customer, and again, for example, in correlated 3D, you could go into File, you could go to Share Results, and you could share those results through Cesium just by making a link. So, and then through Cesium, you can make that link and provide it to the customer, and they can spin around just like we are looking in this data set. And again, that is pretty impressive stuff. So let me zoom back out. And we've got the entire area again. And just again, take a look at how much elevation is in this project. It's quite a bit. So very impressive there. We'll go back to one of the DSMs. We'll go here. And we have it here. And let's see, so we've got, almost 400 meters of elevation here. So pretty impressive. The work that they did, again, looking at the flight lines that went through here, pretty good stuff. So as we go through there, we have 3D model as well, but it's a forest, there's really no point in doing a 3D model of farmland and forest. It doesn't really make a lot of sense, but you could do it right there. We have our orthos, and I'll go ahead and load those. And we'll turn off the imagery again. You can see I'm just doing all of this through the project tree. So here are the orthos, and you can see as we look at them, it's not color balanced. So you've got different times of day, different flight lines. You can kind of recognize that in the flight lines that were flown. So you've got that. And then we also have our mosaic. And here you can see the mosaic has done a great job of color balancing that image right through here. It can't take out the clouds. Again, you could probably do some modification outside of correlated 3D to remove the clouds. Correlated 3D will do its best to take out the clouds, but sometimes you just can't do it. So that's a good example. Now, beyond this, let's see. So with our 228 images, let's see if we can pop into mosaic editing for a moment. Here we are. So we have only got one block. So that's good. It's not that big a project. Correlated 3D can deal with 228 images, no problem in a block. And it'll take a minute for it to load here. Here they are. So here we've got our seam lines for our orthos. And again, if we were in an area where we had, urban issues and we had to check them out and do some modification, we could do that. But everything looks pretty good here. It's saying we're confident. Again, a big reason for this is the altitude that it was flown. The higher you fly, the more information you get within each image frame, which makes it easier for software to match information in between joining images. So we see that there. One of the new features of correlated 3D, as I jump ahead of myself, is that when you select an area within a block, so we'll just go here, it is now going to show us the two adjoining orthos, three actually, that we're working with in this area. And I'll go ahead and zoom in here. And you can see those orthos. And this is actually the seam line that I was touching. I can grab it and move it. So we see that. I'm moving the seam line. And it's showing us what the results are. And then these pink buttons, pink dots, allow us to move more than one seam line at the same time. So now I'm moving seam lines between two images, and we'll let that set. And so especially working at high altitude, this is very nice. Very nice to be able to work around certain areas with seam lines. If we had high enough altitude imagery, we might even be able to take out these clouds this way. But we can also display not only the ortho, but the mosaic. So now it's displaying the mosaic. So we see that it's more color balanced, and you can zoom out and you can see that again. If I go back to display ortho, it'll show you the original, and you could tell like where the seam lines are, that it's still holding the color for that specific image. So you've got that options. Now you can also discard any changes you've made, which I will go ahead and do. So I've discarded those changes, and we can look at another option, and this is it's a ortho patch option. So if I said, for example, maybe I wanted to try over here. So now we have a series of images that are associated with this area, and we can load them and look at them. 1, 2, 3, as we go through. And you can see, I'm probably not going to be able to eliminate that cloud very well. At a minimum, it's going to be at least that size. So what have we said? This is the area that I want to keep. Let me see. As opposed to these up here. Let's say I want to patch that area in. Let's go and just draw a patch and say, this is the ortho I'd like to work with because it's showing the least amount of cloud. And let's hit save. Now it's updating the mosaic. You can see what it looks like right now. It's going through the update process. And let's see if we reduce the size of that cloud in the area. There we go. Looks like we minimized the size of that cloud a little bit, so that's kind of nice. Another nice feature of the patch tool. Of course, you've got seam line selection, you've got replace a series of points, again, move, add, and delete. Oh yeah, we can also turn all the seam lines on and off. So you can turn them on and off and see your product as it is in the final state without all of the seam lines. So that's kind of nice to see. And there we go, there's the change I made. So any changes I made are in blue, so we know they're done. And I would say for all intents and purposes, this looks good. So we'll go ahead and leave the seam line editing. So the other thing Gordon wanted to mention at the end of our conversation was tiling the mosaic on export. So right now, let me go ahead and turn off the reference images, and we'll go ahead and turn that off. So we can see the mosaic, and Gordon has a couple of shape files in here. He has one that is similar to the national tile grid in New Zealand. So you could tile this way, and of course, this is 500 by 500 tiles. It would be small enough to transfer or load into some kind of internet server, so you could display the data and so forth. So that's one option. And the other option, he has two landowners here, so you could tile or clip the mosaic by these shapes. And for example, I'll go ahead and just turn off the mosaic so you can actually see the shapes. Bear with me here. So here are the shapes. You could tile by those and then just provide those to the landowner. So that's something you could use, visually, which would be, just their property. So you have both those options. You can do that right here in File, Export, Mosaic, and then you would just go down here to the tile, the file that you want, load that file, and let it rip, and it would go ahead and create those mosaics. Of course, you still want to give it a mosaic folder, and you've got a couple options on how you want that exported. So as a GeoTIFF or a GeoTIFF with TFWs, or compressed, so you have that as well. I think that's all we have to cover. So I'd like to thank my guest, Gordon, for joining us. Gordon, thank you. I'd like to thank you, the viewer, for joining us as well. Remember, this webinar, plus our previous webinars, podcasts, and other information can be found on our website, simactive.com, under the Learning tab. Once again, thanks for joining us. Until next time.